Hello students, in this video we are going to see some examples. First example is test for convergence. Test for convergence, in which first is integration from 0 to 1 sec x upon x into dx, and second one is integration from 0 to pi by 4 1 upon root of tan x dx. Okay, now we'll solve this first. See here students, we know that, or we can say here, since mod sec of x is greater than 1 for all x's belongs to closed interval 0 1. Why this is? Since mod of cos x is less than or equal to 1 and its reciprocal, that is mod of 1 upon cos x is greater than or equal to 1. Okay, but here we will use comparison test. Okay, so mod of sec x upon x is obviously greater than 1 upon x. Okay, so let f of x is equals to sec x upon x and g of x is equals to 1 upon x. Okay, students, what does comparison test says? Comparison test says that f of x is less than or equal to g of x if integral g converges, then integral f converges. Okay, and if integral f diverges, then integral g diverges. Okay, this is our comparison test. Okay, now here we have a comparison. F of x is greater than or equal to g of x. Okay, if this g of x diverges, if integral from g of x dx, integral from 0 to 1, this integration from 0 to 1 sec x upon x, not sec x, it is 1 upon x into dx. This integral is divergent. Integration from 0 to 1 1 upon x dx is divergent. Why this is? This is by p test, because this integral is of the type integration from 0 to 1 1 upon x minus 0. Okay, because this integral is unbounded at point 0. Okay, x minus 0 raised to p. So by comparison test, what happens? Integration from 0 to 1 sec x upon x dx divergent. Okay, now we will solve second part. Second example is here f of x is equals to 1 upon root of tan x. Okay, x is belongs to closed interval 0 pi by 4. Okay, here we will use mu test. Okay, now limit x tends to 0 x raised to mu f of x is equals to limit x tends to 0. Why limit x tends to 0? Because f is unbounded at x is equals to 0. Because f is unbounded at x is equals to 0. Limit x tends to 0 x raised to mu root of x cos x upon sin x, because this is 1 upon root of tan x. If we simplify this, we will get root of cos x upon sin x. Now choose mu is equals to 1 by 2. Why here we have choose mu is equals to 1 by 2? Because to get the limit x tends to 0, x upon sin x is equals to 1. Okay, so limit, choose mu is equals to 1 by 2. So limit x tends to 0, x raised to mu f of x is equals to limit x tends to 0, x raised to mu is 1 by 2 upon root of sin x into root of cos x, okay, which is equals to limit, we know that this limit is 1 and limit x tends to 0, root of cos x is 0, root of cos x is 1. So we get this limit is equals to 1. Hence by mu test, given integral is converges. Given integral converges. Given integral converges. Okay. Let us take one more example taken. Prove that integration from 0 to 1 sin x upon x raised to 3 by 2 dx is convergent. Solution. Let f of x is equals to sin x upon x raised to 3 by 2. See here students, this is an improper integral of second kind. A and B are real values and this function is unbounded at point x is equals to 0. Okay, f is unbounded at x is equals to 0. We use here mu test. Again, choose mu is equals to 1 by 2. See here students, this is a x raised to 3 by 2. Okay, so if we choose x raised to, see here, if we choose here mu is equals to 1 by 2, then we will get x raised to 1 by 2 into sin x upon x raised to 3 by 2. Okay, this x raised to 3 by 2 can be written as x raised to 1 by 2 into x. So this will become x raised to 1 by 2 sin x upon x raised to 1 by 2 into x. So x raised to 1 by 2 get cancelled. So we will get sin x upon x. So as x tends to 0, sin x upon x is 1. Okay, means to get the limit x tends to 0, sin x upon x is equals to 1. For that purpose, we will choose mu is equals to 1 by 2. Okay. Therefore, limit x tends to 0, x raised to mu into f of x. Actually, here x raised to mu means x minus 0 raised to mu. But x minus 0 is x. So, there is, you can write x raised to mu. X raised to mu, here we have chosen mu is equals to 1 by 2 into sin x upon x raised to 3 by 2. So, x raised to 1 by 2 into sin x upon x raised to 3 by 2 can be written as x raised to 1 by 2 into x. This gets cancelled. Sorry, here is limit x tends to 0. Again, here is limit x tends to 0. So, we will get limit x tends to 0 sin x upon x. So this is equals to 1 one which is different from 0 nor infinite, which is different from 0 nor infinite, and this mu is equals to 1 by 2, which is greater than 1. Sorry, it is not greater than 1, it is less than 1. Therefore by mu test given integral is convergent. Why this is convergent? Because mu is less than 1 and limit x raised to mu f of x, which is different from 0 nor infinite. That's why by mu test given integral is convergent. Okay. Now we will see last definition of this chapter, that is Cauchy principal value. Definition: Cauchy principal value of integration minus infinity to infinity f of x dx is defined as limit x tends to 0 integration from minus infinity to infinity f of x dx. Okay, the Cauchy principal value is denoted by CPV. Okay. See here, student, the given integral may be divergent, but it can have a CPV. Okay. The given integral may be divergent. But it can have CPV. Okay. As shown by the following example. Okay. Example is find CPV of the divergent integral integration from minus infinity to infinity x cube dx. CPV of integration from minus infinity to infinity. Here integral is x cube dx, which is nothing but limit x tends to, here is not x, here is s tends to infinity. This is from minus s to plus s. Okay. So here is s tends to infinity, integration from minus s to s x cube dx. Okay, this is nothing but limit s tends to infinity, integration of x cube is x raised to 4 upon 4. This is from minus s to s. Okay. Limit s tends to infinity, 1 by 4 is constant, so take it outside, in bracket remains x raised to 4. Put upper limit and lower limit. So this is s raised to 4 minus s raised to 4. So as s tends to infinity, okay, so this will become limit s tends to infinity, 1 by 4 into s raised to 4 minus, here minus s raised to 4. This 4 is even. We know that minus 1 raised to 4 is 1. That's why this is h raised to 4. So this will become 0. So this limit we will get 0. So CPV of this integral is 0. Okay. But actually this integral is divergent. But let us take one theorem. If f is continuous, if f is continuous in open interval minus infinity to infinity, and if integration from minus infinity to infinity f of x dx converges to a, then CPV, Cauchy principal value of my integration from minus infinity to infinity f of x dx is equals to a. If f is continuous in this interval, and if integration from minus infinity to infinity f of x dx converges to a, if integral is converges to a, then Cauchy principal value of that integral is also a. Okay. Students, here write down one note. If the integration from a to b f of x dx, when it is integral unbounded at some point C belongs to open interval AB, then the CPV of integral from a to b f of x dx is equals to limit epsilon tends to c plus integration from a to c minus epsilon f of x dx plus integration from c plus epsilon to b f of x dx. Okay. See here, students, when your integral is unbounded at some point which is belongs to open interval AB, at that time CPV of integral f of x dx is equals to limit epsilon tends to c plus integration from a to c minus epsilon. Means first of all you have to break this integral from a to c to b. Okay, this is upper integral, so here we minus epsilon, and here this is upper limit, so here we subtract epsilon from c, and here we have add epsilon in c, so we will get CPV of in this integral is equals to this. Okay, let us see one example based on this note. Example is find the Cauchy principal value of I is equals to integration from minus 1 to 4 dx upon x minus 1 cube. Okay, so CPV of, first of all we will write here what is f of x. F of x is equals to 1 upon x minus 1 cube. This interval is from minus 1 to 4, and f is unbounded at 1. So this one is belongs to this interval. F is unbounded at x is equals to 1. and one is belongs to open interval 4 comma minus 1. Okay, now so CPV of integral from 1 to 4 dx upon x minus 1 cube is equals to integration, limit epsilon tends to 0 plus. Students, in note, make one correction where I have given you epsilon tends to C plus. So make their correction, there is epsilon tends to 0 plus. Okay, limit epsilon tends to 0 plus integration from -1 to f is unbounded at 1, so here is 1 minus epsilon. F of x is dx upon x minus 1 cube plus integration from 1 plus epsilon to 4 dx upon x minus 1 cube. Okay, this is nothing but limit epsilon tends to 0 plus, this will become integration from -1 to 1 dx upon x minus 1 cube plus integration from 1 to 4, because epsilon tends to 0, dx upon x minus 1 cube. Okay, solve this integral, you will get a value 5 upon 72. So CPV of this integral is equal to 5 upon 72. Okay. Okay, we will stop here. Here your second chapter is over. In next video we will start third chapter. Okay, thank you.